we were able to cover 3 charts, 4 but combinedly 3. So starting with line plot, scatter plot, and bar chart, we have also seen one variation in bar chart, which is horizontal bar chart. And from the question of one of our team member, we also saw how to annotate each bar using ax.annotate. This is what we have covered yesterday. And today, as per our next agenda, we will be seeing pie chart, then histogram, then box plot. Okay, so starting with pie chart. So in what areas we basically use pie chart is whenever you want to show percentage distribution of certain categories in maybe 1 year or 2 years or so on. Something like maybe you want to show what is the cost distribution for 2019 or something else, like whatever it is. So right now the data which we have doesn't have 5 to 6 categories, but we can check how that pie chart may look like, and then accordingly see accordingly vary or modify the data to make it more understandable. So coming to the code part, let me kind of run this all stuff first. Yeah, we have all things in place right now, starting with pie chart. Yeah, so you can simply say df custom, right? Yeah, df custom dot set index year dot loc. We have seen loc in pandas. Why we are using loc, you can recall right now. We are trying to identify one particular value from the data frame, okay, and associated elements for that particular data frame. So we are using dot loc. So I'll choose what we have. Okay, let me choose 2019 for this. Okay, dot plot, and inside that I'll just pass on kind pie, and then simply say plt dot show. So now you can see for 2019 we were able to kind of see what is the cost versus sales distribution. Okay, so in the same way, now if you have some different categories, if you have 3 or 4 more columns apart from sales and cost, if you have expenses, if you have wages, if you have something else, for 2019 you will be able to kind of see the distribution of each financial measure in one single chart. So these 2 lines represent pie chart, and as we are already following some process of mentioning everything here, I'll be writing the same thing. Okay, so pie charts are used to show proportional or percentage, or whatever it is, proportional slash percentage distributions of different categories, and always this will always show up to 100% total. Okay, so like 100% total will be considered by default. Nothing but any calculation which you might do or using pie chart will be computed to 100% and then distributed accordingly within 100% to different categories. Something like maybe let's say that we have sales and cost, like we have sales 52 rupees and cost is maybe 48 rupees. Now this total is 100, but what if it is not 100? What if it is 110? Okay, so what happens now? 110 will be considered as the 100%, and then accordingly percentage distribution will be done. Okay, so you need to be very conscious about this thing in pie charts. You may not always see the absolute numbers, but you'll see the percentage distributions, and on that reason you can assume that, or it is a thumb rule, not even assumption, it's a pure thumb rule that anytime pie chart will take or compute anything to 100% total. Any doubts in pie chart? Or you can modify the data, add more columns, see if this is categorized into more sections or not. I can wait a minute here to check and think about this. Then we can move on to histogram.
I know sorry. Can I share my screen to if you guide me to plotting? It's better.
Yes, of course, I can do that.
So you need to guide me from beginning. Import matplotlib.
Yes, matplotlib dot pyplot as plt.
Pyplot as
plt. As plt dot yeah. Yes.
Okay, now we need to fetch the data, right?
Yeah, I have given some custom data. Let me paste the data on the chat.
Okay. I mean, we have previously with us, right? Amazon sales data. Can we do that from?
We can use that. The problem with Amazon sales data, which we have faced in last couple of days, was as the data is very huge, it is taking very huge amount of time to bring up charts. Okay, so instead of like to decrease that wait time to see the chart, we have created a small custom data set or data frame, you can say. I have on the chat. We can use that for now, and later you can try it out. You can try the same thing out with Amazon data frame. That won't be a problem.
Okay. When we have this, no. Should I paste this?
Yes, paste and run. Yeah.
What is this error run file? Okay, it's already run. There is no error, right?
Ran. It ran, and as we are not printing anything, it is not showing anything. Now you can just print df underscore custom, which will print the data out.
Df underscore custom. That is.
Or dot head with 1 or 2 rows or maybe 3 rows. df underscore cus. We haven't finished it. The variable itself in line number 12, and dot head.
So let's.
Yes.
Okay, the data is like this small table, right?
Yeah, very small table. So now what we are trying to do, we are trying to kind of see how how we can leverage this data to see to present each type of chart, starting from line chart, ending with box plot. So do you want to start with line chart, or do you want to start with pie chart from today?
I'll go with the line chart. I mean,
okay.
I'll have a practice, right?
Okay, sure. So starting with line chart, just to kind of recap, as everyone is here. So line plots are basically used to visualize continuous data, which over some intervals, or maybe on to see some trend over time period. Maybe assume that you have 12 months sales data. You might see what is that sales looking like month over month. Even in our particular data which we see here, we are trying to see what is the sales from starting from 2017 to 22. Okay,
Correct.
so we are trying to see relationship, or maybe we'll see where is a dip, where is it increasing, where is a drastic change, or so on. So the syntax starts like this: df dot. You should be writing in here.
df dot
Set underscore index.
underscore,
And this set underscore index is not always required. Why? Because right now okay, let me start like this. So index is a column which will represent the serial like unique serial number for each row in our data set. So right now in our data set we don't have any index column. So we are trying to set the index to year column, because year is the unique column which we are referring to. So set index starting with parenthesis, normal braces, not curly. Yeah. Normal brace,
Okay.
like the one. Yeah.
Okay.
Yes. So just put year in quotations.
Come again.
Year in quotation marks.
Okay. That's year.
Yes. Dot plot. Come outside the bracket. Yeah. Dot plot. And again you need to open brackets back. And inside we need to say what kind of plot we need, which refers to kind equals to line.
Kind. No, it should be in inverted commas or no?
No, kind should not be in inverted commas. Line should be in inverted commas.
Kind equals to line.
Yes. And the next line will be plt dot show.
Dot show. But it is showing some error, undefined df pipe flicks.
Yeah, because you wrote df. Instead, you need to write df underscore cus.
Yes.
Yeah.
Yeah.
And there is a space between plot and brace as well.
Will it make any difference while trying?
Sometimes if ID doesn't understand what it is running, it might throw an error. plt.show will it is a method actually, so it should have open and close parentheses.
The show should be in open and close.
No. After show, you need to just open and close.
You need to close the argument.
Because it is a function inside matplotlib library, you need to close that. Yeah.
Okay.
Now you can check in the plot section of the console. On the top, you have just beside files, you have plots. Yeah, just there itself. You are in help section. Go on to just beside that. Yeah.
Okay.
So now you can see both the plots. Like for sales and cost, you were able to see the line charts.
Okay.
You can actually filter out with only 2 columns, and then you can only plot 1 column as well. That is possible. Okay, so here we want to kind of plot both the lines together. That is the reason we did not mention what is y-axis. So whatever the number of columns remaining are available in the data frame, it directly took as both should be plotted, and it represented both the lines.
Okay.
But instead you can also say what is x, what is y. That is also possible.
But here I haven't mentioned anything, right? Direct plotting is how this plotting happened.
Yeah, that is what I'm saying. So when you said set index year, by default year will be considered as x-axis.
Okay.
Okay, so whatever remaining columns will be there, those will be represented as y-axis. Yeah. Now if you want to only plot 1 column, not like only year versus sales or year versus cost. Okay.
Can we try that?
Yeah, you can do that. So you need to filter out. Okay, you can do one thing here in line number 16 itself. Just copy line number 16, 17 back. Create a replica of that below. Yeah, and then in line number 20.
Number 20.
Yeah, just before the dot, df cust dot we have, right? Just before the dot, open square braces.
Okay.
Before the dot.
Before the dot.
Yeah. So we are trying to filter out the number of columns we have. So square braces. Inside square braces, only add year and sales in quotation marks. Year comma sales. And close the brace. And now you can run these two lines.
So this set index will be there, right?
Yeah, set index will be there. Nothing will be changed. Only that thing.
Set index. Okay. This is there.
Okay, so there is a problem. Just add one more square brace. As it is a two-dimensional data, we need to have two square braces in front, and you should be enclosing with two square braces at the end. Not there. Here itself, before the dot.
Before the dot here.
Yes. And now you can run again. It did not run yet. Let's wait. Spider is actually slow a bit in plotting charts. I don't know why.
But the navigator, Anaconda navigator is a bit instant. It gives instant results, right?
Jupyter Notebook gives very instant results.
Jupyter, yeah. Jupyter.
Yeah.
And it's quite handy. There is no multiple windows like this, right?
Yeah,
right
no.
Consoles and plotting.
Nothing like that. It will print everything then and there. See, now you can see you only have one line. So there is another way of doing this as well. So yesterday also we were discussing this. Right now what we are trying to do, we are deciding the data frame first and then plotting the chart next. Okay, so if you even see the line number 20, we are deciding what we want to plot, like what data frame, nothing but the data, and then we are applying the plot. But we can do in reverse. Firstly, you can figure out what plot you want to plot, and then supply data to the plot. So something like you in line number 23, you can start doing something else. I'll let you know how.
No, I think my PC is not responding properly.
No worries. The Spider is actually slow. Even I faced this issue yesterday.
Given that it takes initial time to, it takes a lot of time to open itself.
Yeah.
Yeah, 23. Yeah.
Yes. So here we can do plt.plot.
Plot.
So here what we are trying to do, we are calling the chart first, and then now we'll be supplying data inside. So plt.plot inside the normal braces. Firstly, you need to supply x-axis. Nothing but you need not write x equals to. You can simply write df custom of year, because the x-axis is our year. So df underscore custom square braces year.
df custom. df custom underscore. This is
square braces. Single square brace. Yeah, and quotation marks year, followed by sales, like commas df custom. No, not here. Again, this is x-axis purely.
Okay.
The first variable is x-axis. Now comma y-axis.
df again cus.
Yeah, df again cus. And now this time you will be giving it sales or maybe cost, whatever it is.
Okay.
Any numerical column.
cost. Let's try to cost is like this one.
Yeah, and you can simply close, and then again plt dot show in line number 24.
So,
You can see this plot. So right now, you can observe one thing here, that you were you have to specifically give one variable for x, one variable for y. If you want to combine two different line plots into one, you have to replicate line number 23 in one more time into line number 24, and just move that plt dot show below. Yeah, just move it to line number 25. Yeah, and now change it to sales in line number 24. Yeah, change cost to sales. And now you can run these three lines together, 23, 24, 25.
okay, these both lines can be merged and plot, huh?
Yeah, exactly. So the one which we were able to see on the top will be replicated here.
Okay, this with this, can we add multiple charts? Like, can we put bar graph into this chart?
Of course, you can do that.
Like yesterday, Bharat has asked, right, to put legends and all, like
everything. Even there are. Okay, let's do one thing. Here itself in line number 25, like you can move plt dot show to line number 26, and in line number 25, let's write something which says plt dot legend.
Legend.
And just open close brace. That's it.
Okay.
Yeah, just run these 4 lines again.
No artist with label font to put in legend. There's
okay, do one thing. Just add look inside that. Just add LOC equals to nothing but where you want to kind of put that legend.
Okay. End of the line.
In quotation marks, just put upper left, upper space left. Yes. Just run these 4 lines.
Not when legend is called.
It should actually do that. I think it is. It is no, nothing. Not anything with spider. Let me check. I am just going to documentation. Give me 1 second. It actually works for other plots. Meanwhile, you can do something. You can add a scatter plot in line number 25 instead of legend. I'll check for like what legend and come back. Just plt dot scatter and then supply x axis and y axis. Yes.
X is equal to like year and comma y equals to size. Can I run only these two? Okay, I need to run 4 lines, right?
4 lines, yes. And you can also
so this is it. That's it.
No, there is some issue. Okay.
Some error. Yeah.
X equals to year, y equals to sales. So don't pass x equals to year, y equals to sales. Pass the variable same like above, df underscore custom year, and
okay.
Yeah, instead of year you should pass df underscore custom year.
Like here, comma Should it be okay, or should I add another brace somewhere here?
No,
No.
that should be okay. Let's check.
Oh, good.
So you can also add the same scatter plot for cost as well. So right now you only have for sales. The same thing you can create for cost as well.
So plotting part is not that hectic, but before plotting anything, we need to filter the data, right?
Yes. So data is the ultimate thing. Yeah. Plotting is very easy, and you will have like very vast documentation is available for plotting, and you can always go through documentation and simply copy paste lines and then plot it. Nothing hard. So now you can see that there is a dynamics involved automatically to represent data properly. Orange color line has been put with blue color dots, and blue color dots has been put with orange color dots. Like blue color line has been put with orange color dots. So this all dynamics will Python itself will take care. If you even want to change colors, you can do like you can also change colors accordingly.
So we can customize everything, right?
Everything. Yes. Instead of dots, you can use stars or maybe any other symbols. Okay. Even you can like work with the thickness of the line. Okay, so all these things you can definitely customize. So to do this, let's also do one more small exercise here itself.
What if we only run these 25, 26 and 27 lines? There will be only scattered dots, right?
Sorry, if you only run, yes, only dots will be there, no lines will be there.
Okay, yeah, got it.
Yeah, so now to kind of have a add-on exercise for this. Okay, now can you kind of only add plt.legend. Let's see if legend comes up. Usually it should come. I'm not sure why it is not coming up.
No, okay, I've tried on navigator.
No, it's okay. Let's do one thing. In line number 23 and 24, coming to line number 23, just add one more comma inside the braces. Say label equals to quotation marks, add cost, because it is a cost thing you want to show. You can put it to your custom, like you can change the font, or it is just a label which you want to say, okay, this is something this. Okay, it is not a variable. You can choose like capital letters or small letters.
Yeah, correct.
Yeah, all those things you can use. Even replicate the same label for sales as well in line number 24.
Line number 24 also. Let's try this. Label equals to. Can I give a font size?
No, not font size, but you can give sales. Maybe in all capital letters for now.
Capital, can I write capital here?
Sales in all capital letters. Even you can give like what in all capitals, that will work. And now can you run all 23 to 29, sorry. I feel that PLT legend is unable to find the labels. So we passed on labels. Okay, so let's see if legend comes up right now. Hopefully there is no error this time. You can see the labels on the top.
Upper left. Okay.
Yeah, upper left.
By default is upper left, right?
Yes, you can change that location to upper right or down right. Okay, you can even customize that as well.
Okay, move again. That is pretty slow again. It should be in quotes, huh?
Just say LOC equals to, and then you can write anything. Yeah, upper space right. And if you want to change colors of lines, simply you can add one more comma after label equals to cost, and then say color equals to
pink,
and then you can just pass on any color, maybe green, red, whatever you want to.
Oh, so since we are using you American accent, the syntax is right? I mean,
No,
spelling of the color.
all smalls, like nothing but all small letters. You can use anything. Yeah, you can use red as well, like any black as well. You don't, yeah.
Okay, the red line is here. Oh no.
It's correct only. Sales is the top line, which is
Okay.
represented in red, and then cost is in green.
Green, right? Okay.
Yeah. So even if you want to increase the line width, and if you feel that okay, you can do the same thing with scatter plot also. Right now you have blue color dots and orange color dots. You can change those dots color. Okay, and
Color equals to, suppose if I add blue already is there, no?
black looks better, I guess. Black, which you can identify. Yeah.
So if I give color to one label, the alternative line have a different label. Python itself adjusts it, right?
Yeah, it will like right now, as already the dots are visible, it will not adjust. But if you don't give any color by default, it will take its own color, contrast color for whatever the color it chooses by default.
Okay, let's see, black and what is color? Yellow. Yellow is already there, huh? No.
Yeah, you can see that color changed. And even now, if you feel that line width is very small, like what small, and you want to increase line width of the lines, then in line number 23, again one more comma, and just add line width without space. Line width without space, yeah. And then equals to any number, like let's start with 2, 3, or 3. Okay, 23 will be very fat. Okay, 3 or 4, 5, yeah, should be fine. And accordingly, we can tweak if you feel.
Let's see first. I mean,
Yeah.
let's try 4, I guess. This should be fine. I think for plotting and all, if you guide us, we'll make it. Oh, let's increase. But the label, I mean, the scatter plot thickness.
Yeah,
we can
now
increase, right?
you can increase the size of scatter plots.
So we need to increase the size right here.
Yeah,
For scatter
you
plot,
should.
size only.
You can use directly size itself. S equals to or simply S equals to also will work.
So the 5.
S equals to some 10 like dot. Okay, let's put 5 and then just check, and accordingly we can tweak. No worries.
8. Let's see.
Actually, those are small, so just give maybe 20, 30, or 50, because no, for the scat for dots, not for lines here.
Still,
Yeah, you can use 50 or 100. Let's put 100 for now, so that maybe put red. Yeah, black is also fine. 100 for now should be fine. You can see some definitive size. Yeah, 55 should be still okay.
Yeah, this is better.
Yeah. Now you can see that maybe dot is not representing the scatter plot well. You want to change it to X or plus to kind of represent better. in line number 25, you can just extend with one more comma and then say marker equals to, and in quotation marks you can give any kind of quotation marks, like maybe give give S. Okay, let's see square boxes. Yeah, small s. Yeah, just copy the same thing for the next line as well. You can choose X as well. Like maybe one you put it to S, the other you put it to X. We can see both the variations in one single plot.
So this marker will what makes us different?
Marker is nothing but the dot shape. You are changing now from circle to square.
Square, okay.
Okay, instead of yes, put X.
Okay.
Yeah. Yeah, you can run now and then see the variation. So customizing is very easy.
Yeah, correct. But oh no, what is this? Name T is not there. Huh?
Somewhere T, an extra T. Ocha, you did not select the whole thing in line number 23.
Okay.
Yeah, you should select that.
Okay, this X is like as it is, it's cross mark.
Yeah, cross mark. You can also use plus, or you can use
any symbols. Rather
not any, but there are some limitations for what symbols you can use, which I know are plus, cross, square, and circle. We can see the documentation if any other symbols are allowed.
Okay.
Yeah.
Let's try another chart. Like yesterday, you tried bar chart also, right?
Yeah, we tried bar chart. So next comes the bar chart. So firstly we tried with both of these line and scatter. Now you can also add maybe let's firstly create a bar chart individually, then combine and see how it looks like.
Yeah, that's
okay.
Better.
Yeah, so in line number 29, you can start with writing a bar chart code.
Line number 29, huh?
Yes.
Okay. Okay. So df underscore curse. No. So how we need to give it that bar chart code? Like
it is df underscore custom dot set index. Again, you need to use for year.
Set year.
No braces, no square braces. Df underscore cus dot set underscore index. You can copy line number 16, replicate it, and simply change kind equal to bar. That's it.
16 and 17 both.
Yeah, both. Okay.
Index kind equal to okay.
Yeah, just change it to bar.
If I run these two lines,
these two
should add. Oh, but it's showing both.
Yeah, so again, what you need to do to kind of only show single is you already have the solution in line number 20.
0, right? So again, the kind in we need to change it to bar, right?
Yes.
So here df custom, here sales, and set index here. Okay. But here we are defining both, right? Year and sales.
We are only
putting set index only here because we need to have an x-axis on year. I mean, for x-axis we need to have year.
Nothing like that. Okay. See, in line number 23 to 27 or 26, we never said year is an index. So what we are trying to do here in line number 30 or 31, as our data frame doesn't have a unique column which will say this is the index column, we are explicitly defining year as an index column. Okay, so whatever you set index will by default, yeah, so the chart itself will pick as x-axis.
Okay. Okay, here we have sales and cost. What if I change it to okay, all the data is here, right?
Yes, all the
Sales
data is
here,
there.
right?
Now, if you only run 31, 32, you only see one bar of year-end sales, not the cost.
Because we have defined that year-end sales only has to be shown in the
We
bar chart.
filtered
Right?
out. We filtered out the data frame to a sub data frame which only has two columns, year-end sales, and then we have plotted a bar plot. So that is the reason it only
Only
showed
showing.
sales.
Yeah. So we can customize here also, like we can add column here, color of the bar. We can
Yes,
add
you can add everything. Yes,
legend also here, right? To show
legend is already there on the
there.
top. So
Okay.
you so this is the
What if
advantage. Sorry.
if I want to show the cost over here, like what is the top number in
That
this
is
year?
called annotations.
Annotations, yeah.
We can actually add annotations when we are uh, okay. We can try. The problem with annotations is we have to take the whole figure as a separate figure. Okay,
Okay.
and then plot the annotation. Something like now this whole 31 line should be inside a variable. Okay.
Mhm.
Yesterday we have seen this actually. So okay. Let's cover this
Okay,
in the
okay.
last.
Let's not go to the previous session. So let's try this pie chart and all. I'll go and try again with myself.
Yeah, no worries. So now coming to let's skip the let's put the annotations to the end. So right now, if you want to also add this bar chart into the plot which we have done earlier, like with the line and the scatter plot, in line number 27, like you can push or create a line space there, insert a new line in line number 27. Line number 27, just above. Yeah, in there you can just simply say plt dot bar, and inside that
X is equal to
a df of df cus of year is your x-axis, and maybe
so we need
sales
to
are
put in the square braces, right?
square braces, same like above, nothing different,
Okay.
comma, and like sales or cost, maybe whatever you want to choose.
Okay. We can add labels and all later part, right?
Later, yes.
So that's all. We can try this only single this line, right?
Yeah, plt dot show also should be run along, or else it will not show anything.
It's already there.
Yeah, this one. The
So
bar size and all the thing again you can customize. Yes.
Yeah, correct.
And now you can run all the lines together from 27 to 28. So 23 to 28, sorry.
23 to 28, right?
Yeah.
So what if we run all these three together? Like, oh.
So such kind of customization is not possible in maybe Tableau or Power BI.
Only Python can do this thing, huh?
Yes.
With
So
lot
you
of
cannot,
library.
yeah, you cannot club all the charts together into one chart in these tools, because they have some limits, but Python doesn't have any such limits.
Understood.
Even when you kind of markers when you choose for a scatter plot, these tools can only support dots or squares, but not X markers or O markers and others.
Okay.
Even they have some limitations of how many data points you can plot. and even some other limitations when you do nested aggregations, you will come to that part. If you have a column, aggregated column, and you want to again aggregate that column, no tool will support that. But instead, you can write a Python code, do aggregations over aggregations, make your data ready, and plot your chart accordingly.
Okay.
So that is possible. Now coming back, we can now try the other charts like pie chart, pie, histogram, and box plots.
So, okay. Yeah, let's type pie chart. So we can pull this data over here, right? From set index to it's already here.
Basically, you can simply use plt dot hist and then continue. See, both are same. Here we are enforcing matplot library as our basic thing, and then we are supplying data from pandas data frame. But in line number 34, 35, firstly we are enforcing pandas data frame, and then
we are plotting.
Plotting it. That is the difference. Ultimately, it is same.
Correct. Yeah.
So you can simply use plt.hist. Inside that, you can give data. So now you can show histogram only on any continuous variables. Let it be sales or let it be cost. So only one column you have to choose because it is the distribution of the thing. So df custom of sales or cost, any one column only. Sales, comma, how many bins you want to show it. So bins, bins, bins. How many bins? Bins you can usually take 10 for now. We can see how it looks like and accordingly tweak. And
again plot plt.show, na?
Show is compulsory, yes. But if you in Jupyter Notebook, this plt.show can be excluded always. We can
enter this and run this, right?
Run this and it will plot it then and there itself.
So should I run only these two lines or 34 too?
No, only 36 and 37. Running 34 to 37 doesn't make any sense because it will again plot two different plots.
Okay.
See, 10 bins is very huge for only 5 data points. Okay, correct. So you can choose maybe 3 bins, 2 bins and run. That is the reason those are very far. You can take more data points, accordingly it will work. Nothing like that.
Oh, it's something like this. Closer.
Yeah, so you can choose 5 bar. See, there will be no space in histogram, first of all. Okay, so it is a continuous thing. So if you choose more bins, it might create some space. So we might have to see what is the best number of bins to choose in order to make it continuous. And this space is created here because of the data is quite far from each other. Okay, if you have a continuous column, this probably will not have, this issue won't be there. Nothing but if the values are closely packed, this space won't be introduced.
So upon this, what we plotted here is only sales, right?
Only sales, yes.
But with reference to what?
No, you are not using any reference. See,
only single variable we are showing.
Yes. Plotting, right? So histogram is specially used to show distribution of the data. So now if you want to see where most of the people are lying in, or where most of the sales are happening, or what is the most sale point. So if you can see now with this distribution, we have 2 peaks. One is at 60,000. One is at 75,000. Nothing but you have more peak at nothing but you have more people buying at these 2 peaks only. Okay, either 60,000 or 75,000. In between that, from 55 to 60 or 70 to 75,000. So plotting chart is one different thing, and even understanding the insight from the chart is also something else. So if you kind of plot, okay, let's do one thing. There is something called KDE plot, density plot we usually call it as. I don't remember exactly the syntax. Can you kind of check it on Google, the KDE plot immediately? uh, you can simply type KDE plot in matplot library. That's it. You can choose a new tab over here.
What is that?
KDE plot. Yeah.
For that you need to import Seaborn, right? No.
Not required. You have KDE plot in matplot library as well.
Okay. Kernel destiny estimate. Okay.
Seaborn is also some kind of very good plotting package, but if not, you can for now use Seaborn so that to kind of decrease the time if you already have some ready example.
We can put this data into KDE, right?
Yes.
So here we need to import Seaborn. Huh?
Yeah, import Seaborn and as SNS.
We need to run this line also, right?
Yes. And then simply say, I don't think that will be there. Okay,
No,
this is a good time. We can actually also see how to install packages which you don't have. Okay,
correct.
now you can go to Anaconda Navigator.
I don't think Anaconda is working now. Okay, it's here. Anaconda.
No, yeah, open.
Takes a lot of time in this machine. Yeah, Notepad++ also, which can gives us same result, rather we can say. The Anaconda is only opens in browser, right?
No, it is an application. It will open in your laptop itself. It might take a bit time to open.
Something is running behind, I don't know.
Yeah, it slowly opens actually. Let's wait for it to open. Yeah, it is opening twice actually. Your laptop may not. Let's see.
That's fast. It's an old machine, but it doesn't give any issues. Whereas my new laptop is multiple issues. Did Sri Krishna join the session? I think no. I've asked him to join.
I think it is taking like the application itself is crashing again and again because of no memory space. What you could do, try to type a line in line number 34 itself, or you will have Anaconda prompt. Can you open Anaconda prompt instead of Anaconda Navigator? Just try to check Anaconda space prompt. Actually, Anaconda Navigator has opened here.
Yeah, it's here, right?
Yes. Okay, just click OK. There might be one Anaconda Navigator which is already running in behind. Yeah, still here you can simply write a line, pip install Seaborn, pip space install space Seaborn.
Pip is like package installer, huh?
Yes, package installer, Python package installer.
Okay.
It is kind of package manager which can allow you to install any package which it has in the latest Python version.
Okay.
Yeah,
that's
enter.
it, right?
Yes, enter. And meanwhile, you can also open the Anaconda Navigator. Let it. It says it is already there. Let's check. Yeah, here. Can you go to environments on the left hand side?
Too much brightness, yeah.
Yeah, here you can search on the right hand side. There is a small search bar to search. No, not here. On the right hand side. Yes, search for seaborn. Yeah.
I think
So it is actually loading. Let's wait.
But it's already installed, right?
Yeah. Can you now run that particular line again?
No modular seaborn.
Okay. Let's check. Maybe you are in a different environment, or maybe the spider is not launched from Anaconda Navigator.
Exactly. So from Anaconda Navigator, if we launch Spider, then might have imported, right?
Yeah. Again, there are two different things here. There are two different environments in your Anaconda Navigator. One is Anaconda 3 and one is base. Okay. So we don't know whether Spider has launched with Anaconda 3 or is it launched with base. So we have to check that as well. We have installed Seaborn in base, which is already available. I suspect that Spider might have opened with Anaconda 3.
Maybe.
Maybe. So.
But Anaconda provides multiple IDs, right? This
Yes.
navigator?
Yes. You can see it is already in installed section. Seaborn is already in installed section. Can you check in Anaconda 3 as well if this Seaborn is available? It will load and show. Yeah. Can you select this channel installed to all? Yeah, like just expand the drop down of installed. Yes, and just put it to all, so that if there is no installed version also you can actually check.
Okay.
So here once we see some package which is not installed, simply we can pick that particular package and you can see some option called apply in towards down right, and we kind of click apply and this package gets applied to the environment.
Okay.
So you need not write that line pip install and so whatever this thing.
You can simply search over here and you can right click and apply, right?
Yes, that's it. And you need to click on update index once this package has been
right.
So that it will be associated with your all applications.
So whatever ID we have, that IDs will update with the index.
Yes, latest packages, whatever you have installed.
Okay. So we're taking a lot of time with Anaconda 3. So yeah, since we are not unable to do that KDE, so that's what we are installing Seaborn. Huh?
Yeah, so KDE plot is nothing but it's a curve which will show where is the peak, something like normal distribution. At least we could do something like this. Search for KDE plot in Google, search for images. Now you can relate how the plot might look like in our plot or
it's
our scenario.
Here, I guess.
Any image for KDE plot?
This is right.
Yeah, this you can open any image. So this is a KDE plot, a simple line, okay, with some shaded region is your KDE plot. Sometimes you need not even have this shade. So now apply this particular curve to your box plot, to your histogram, and whatever that peak you are seeing, you will see twice. Or let me search for an image. Let me search for an image.
So I've searched a few images. You can see if it is related.
1 second. I want to. I am just sharing you one link on the chat. Can you open that link? This one, the black bar chart, the black histogram with the line. Yes. So this curve is a KDE curve, and the background plot is a histogram. And wherever it is peak, the peak of the KDE plot also maps to the same thing. And now we have two peaks in our data. Nothing but we can refer to it as bimodal data, because we have two peaks in our data. So this kind of curve or the peaks you will see two times in our data, especially. I can also check for bimodal data in case.
Here.
Yeah. Can we do something? Let me. I am sharing you one more link on the chat. Can you open this? This will be more relevant to our situation. Can you scroll down a bit? Yeah, so you can see there are two peaks in our data. So you can also see two peaks in the KDE plot. Same like this, our KDE plot also will look. Okay, if we kind of drop this line onto our chart, which we will try to see tomorrow again, but it is kind of basic understanding that this is a curve which will kind of come on our histogram as well.
So this is basically gives us an inference that we have two
peaks and the distribution of data where most of the region is lying in. Maybe assume that right now we are seeing at sales or cost. So in which part of or at which price point most of the people are buying. That is what we are trying to kind of inference.
So in in a single chart we can inference both variables, right? Like sales as well as in which price point the most of the population lies.
Yes. Both.
Good.
So this is our histogram. Like it's already 10:06. Do we have to stop today or do we continue with pie chart as well?
Pie chart is like very quick, no? Can we?
Very easy. It is simple. plt.py.
Here, right?
Yes.
Copy these lines, then
simply change hist to pi. And then you can kind of
okay, the bins and all. I don't think it's required, right?
Not required. Bins is not required. Okay. You can pass on sales alone, or you could do something like this. Okay, let's do something like this. Pass on year first and then sales.
Year first and sales. Oh, okay. Where is year? It's here.
Nothing but we want to label years on sales as well. Like which year, what is the sales? Okay, so first will be the sizes. Can you swap sales and year? Like sales should be first and the year should be next, because the labels are the second argument in pie chart. Just move year to after sales. That's it. Yeah. Comma sales. Sorry, comma year. That's it. Remove the year. Yeah, and you can run this.
Figure size also is there, huh?
Yeah, so like what such limitations, you can see this is the size of the image which Python will support, but in Tableau it is kind of more or less. Let's do one thing. Let's not this is actually an ID error. If it is the same thing on
Anaconda platform, it will show that, right?
Jupyter Notebook, it will kind of shrink the image accordingly.
Show that also, right?
In home, just go to home. In home, you'll have something Jupyter Notebook. Yes, here.
Yes, here, right?
Just open this Jupyter Notebook, but you have to again copy everything from Spider to Jupyter.
It's taking time.
Yeah.
So we need to connect it, right?
Let's do one thing. Go back to pie chart. Let's
it's
not
not
label
visible.
it. Let's not label it today. Let's
Let's try
only
on the chart, right?
yeah. Let's only show sales, or else uh, yeah. Let's only show sales.
Sales. Okay, the sales. Okay. Oh, it's like a football.
Yeah. So each distribute. So I wanted to add labels for this sales. Okay. Maybe comma. Yeah. Just add labels equals to labels else. LABELS.
LA.
BELS. You just missed else. Yes, that's it.
Okay.
Labels equals to, and then you give df of year here.
DF.
Of year. Square df
DF
custom.
underscore
Yeah,
first.
custom of year. So it will kind of pop up for each distribution. What is the year of that particular distribution?
Okay.
Something like that. So, and you can also add like legend is not required for pie chart because you are already annotating everything. You can add maybe a box on like a outlined box, and you can also add thick lines between the distributions, and all those things can be customized inside.
So that is customization. We can try it out, right?
Yeah, you can try it out by seeing documentation.
Yeah.
And we have one more plot, which is box plot. This is again same like histogram, works with only one column. We need to kind of supply only one column, which is a numerical column, and yeah, DF
Either
sales
sales or
will be
cost.
enough. Sorry,
Either sales or the cost, right?
cost. Yeah, DF PLT dot box plot PLOT.
Box dot.
And then you can run, and this will basically infer you the statistics like first quartile, second quartile. You
No.
have it in box dot remove dot. Yeah.
Okay.
So this is your box plot. It will show what is first quartile, median, like third quartile, upper limit, lower limit. So in your
It is
data,
upper limit and lower limit, right?
yes. So those are called whisker lines.
Whisker lines.
Yeah, whisker lines. And wherever the box is there, so the whole box implies that 66.7% of the data lies within this box. Nothing but from starting from 60,000 till 72,000. So most of the people or most points of the data are inside this box itself. And your
So this
median
is-
is 65,000.
This is right median, right?
That is a median. Yes. And you can also plot mean in this, but I don't want to get into that customization right now.
Okay.
And
That's good. We can fill this also, right? We can
yeah,
again
you can
customize.
fill again. You can add colors. You can fill. You can make it horizontal box plot. Okay, as well. So all these things you can do.
Yeah,
So
we
this
are
is
good.
basically all the charts. And as I told that we have one more chart like pair plot and violin plot. I would recommend you to try by yourselves.
What is again?
Pair plot and violin plot. Violin plot is mostly like box plot only. Okay, significance is quietly different, but pair plot is kind of a single plot which shows all the relations in one single plot. For now, we can see on the Google how these plots look like. We can check what is pair plot and violin plot for now, and then we can end the class for today. Please search for pair plot.
Oh, this only.
Yeah, pair plot.
Yes.
So this is a pair plot. So depending on how many columns you have, the relation between all the columns will be like what presented in one single plot. So this is a grouped plot. Okay, and all the plots are like relationship between all the columns are in presented in one single. And now we can search for violin plot. and this is violin plot. It is again the same thing like box plot only, but the way the representation of this is quite different. And wherever there is huge bulge, so that bulge represents the median or the most people lying in that particular area. So you can see this particular chart, second row first chart. Second row first chart. Can you enlarge that? Yes. You can now see how it relates with box plot. Both the plots are actually same. It is just the representation of plot is different. That's it.
Sorry, I think it's gone.
You can right click on it and open the image in a new tab. Open image in a new tab. No, you are again opening link only. There is an option to open image in a new tab. Down. Yeah. Yes.
So the box plot along with violin plot, huh?
Yeah, it is both are same. It is just the representation is different. That's it.
Oh, this looks more
conventional. So box plot is more conventional. Violin plot is very rare. Mostly used by statisticians and biologists to show the vast area of distribution where people are more distributed.
Okay.
Yeah.
So this
There
is
just representation wise. That's it. Both are actually same. Nothing different.
So this is the median or the mean, right?
It is median, not mean.
Okay.
Median. You can also plot mean, but box plots by default show median, not mean.
Okay.
Yeah.
You will try by ourselves, I guess.
Yeah. So like violin plot and pair plot, you can try by yourselves.
Yeah.
So this is about matplot library, and we can deal like what NumPy a bit tomorrow.
Yeah. Thanks, Anu. I think it's quite helpful.
Thank you so much. I hope there are no doubts today. If yes, I can wait for a few more minutes to address anything. Sai Navi, I guess you are trying to speak, but we are not able to hear you.